Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Hey y'all, happy Sunday. Hope everybody's doing well. Hope everything is going your way. And nothing but sunshine and green lights. Well, that ain't happening out here in the West. We got rain. And I mean, we got rain. Yesterday we had to go out of town. I totally forgot to mention to my channel members on our 3D printing live stream and last Monday for that live stream. But this too shall pass. I apologize, folks. I wasn't around to host a BS session last night, and it just kind of everything just kind of fell apart. But yeah, we've got rain, and we sorely need it. It's keeping fire activity to a minimum. And hopefully it's heading to Colorado soon there, Stubbs Mom, so you guys get a little bit of moisture to help out in that fight. But anyhows, I got to scroll back up here and try to find them. I can always count on you all to come up with good questions that lead to great topics. And today it was Kimberly Went who came up and said, quick question, Mark. No questions here are ever quick. Kimberly, you should know that by now. Not food related. Okay, there's a stretch. I'm making small shapes and don't want to chamfer tiny things on the router table. Could you possibly do a quick demo on it? Then as we got further into it, it turns out what she wants to do is a roundover, not a chamfer. So using a 1/4 inch pointed roundover bit on the bottom of a board with 3 marking holes, flipping it, doing the same path on the front side filled by a profile cutout. No tabs, using tape and CA glue on it. Okay, so it's a 2-sided project. And you're going to be doing a roundover, I assume on the top and the bottom, just to alleviate sanding. And she says she's using a 1/4 inch point cutting roundover bit. Well, that's not a problem. The method is the same no matter what. But here's something that you got to look out for. For instance, I have a 1/4 inch point cutting roundover bit right here. And this is the, the Whiteside 1572. And what I'll do is I'll put a link to this down in the in a pinned comment as soon as we're finished live here. I can't do it while we're live, and I wasn't fast enough to do it before we went live. So the thing you have to watch out for on a point cutting roundover bit is it doesn't come to a complete, absolute, infinite point. There's a flat spot. Okay, let me show you over here. If you go to Whiteside's website, they show it with a flat spot up here on the very tip. There's a flat spot there. It doesn't go to an infinite tip. So you come down here and they have the CNC profile, and you can download it either as a PDF or as a DXF, and that's all fine and dandy. But when we jump over here into, where am I at? VCarve, and you download that DXF file and import it into VCarve Pro, if we look at the tool outline, it shows it down to an infinite point. And that's absolutely not what this bit is. It does not have that sharp point. And when you add the geometry, that's what you get. When you right-click this right side of the geometry and go to add it to your tool database, it's going to come in as a sharp point. And the bit does not have a sharp point. So what I had to do, and this varies with every bit because no two bits are grounded 100% exactly the same. So what I had to do was I had to get my machinist rule out, and using these old eyes along with a magnifying glass, I had to figure out the width of that tip. And I'm going to say it came out to, let me just take a look here. The tip on this is roughly right at 1/32 of an inch. Am I reading that right? Yes, right close to 1/32 of an inch. The reason I don't use my calipers is because it's a rounded profile. And the further you go down on this tip, the wider it gets because it's going into that radius. Sit, stay. So what I had to do when I entered this into, yes, Kimberly, I have calipers, but I won't get an accurate reading with the calipers. Simply because, as I said, it just kind of flares out and it's real hard to get it right on the very tip. So I measured it on my machinist scale and I came up with 1/32 of an inch. So what they're looking for here is when you go to enter it in the tool database, we need to know half of this tip width. They just want the right half. So I need a straight line over here that's, in my case, a 1/64 of an inch wide. So I had to come over here and draw a little thing on it. And we're going to start here. And we're going to go this direction. And I'm going to use this angle here. The angle is -0. -0. And the length, I don't remember the decimal equivalent of a 1/64 of an inch. So I'm going to go 1/64 equals, and there's my decimal equivalent. And I'm going to add. And of course, it went on the other direction. So close. Now what I need to do is I need to mirror this. And I don't want to create a mirrored copy. I just want to flip it. I don't want to flip it around the job center. I just want to flip it horizontal. That didn't work. All right. I'll just drag it. Thankfully, I have snapping on. There we are. Then join it. And we want one open vector, join, close, and that's the profile that I'm going to use to enter it. Okay? Okay. Mark, is it possible to get a true point? You need a high-speed steel bit rather than carbide. The welded-on inserts make it difficult to grind a point. That is true. However, high-speed steel on a CNC router, I mean, they work great on mills for metal, but I haven't really had any luck with high-speed steel on a CNC because the RPMs are just so high, and they'll dull real quick. And they can get a good true point on carbide. I mean, my 15-degree V-bits, they definitely have a true point. They're like hypodermic needles. So I know it can be done. It's just that it's extremely delicate and you will break a tip. You can break a tip by sneezing on them, I think. So my broader point in all this is to save you a bunch of sanding. So when I go up here to my tool database and I come down here to I got my roundover bits separated here, go into my 1/4 inch radius. That's my Whiteside 1572. You see it has that flat spot in there. Okay. Now, Kimberly says, I just use a tiny offset to avoid the ridge on the sides. That's exactly where I'm going, Kimberly. In this case, that offset is going to be the diameter here. Okay? So that'll avoid that ridge. So the way we're going to set this up is I now need a, and this is all the information that comes on that DXF or the PDF, either one. Because, of course, that's the perfect time to get some advertising in. So I'm going to go ahead and get rid of all this because I already have that bit in my... Hello? Oh, come on. Come on, machine. You can do it. I got a lot of stuff going on with this poor computer. Come on, you can do it. You can do it. No, we're going to wait for the program to respond. You could. Thank you. All right. So let me make a polygon here. We're going to make 6-sided, and I'm just going to do this. All right. Then we'll close that. Now, I know you're doing 2-sided. Okay? I know you're doing a 2-sided, but this is the same method no matter what you're doing. Okay? So I'm going to select this. I'm going to bop over here to a profile toolpath. Now, you're doing the round over on the top, then you're flipping it over and doing the round over and a cutout. I'm just going to demonstrate it single-sided, but the method is the same. Okay? And here's what we're going to do. I'm going to decide how deep I want that round over to go. I want the round over to be slightly less than the radius of that bit. So it's a 1/4 inch radius. I'm going to go with a 0.23. Okay, I don't want it to go down to exactly the radius of that bit, because unless you have surfaced that material just before you start carving on both sides, that surface is going to have a little bit of, I'm using my hands like you can see me right now, that surface is going to have a little bit of irregularity to it. So you may end up with the top of that radius cutting down into the top surface of your piece. And that just introduces a whole bunch more sanding that needs to be done. So we're going to slow it. We're going to back it off just a little bit to account for that irregular surface. And then there's going to be some hand sanding no matter what. The rest of that round over can be cleaned up with a little bit of sandpaper, but nothing like what you would have to do if you just left a straight cut out with the end mill. So we're going to cut 0.23 deep. We're going to select the proper bit. In this case, 1/4 inch round over, point cutting. Select. And I'm going to do this without an allowance offset so you'll see what I'm talking about. Okay? We're going to cut on the vector. All right? And I'm not going to do anything else with this toolpath. This is just for the round over. And I'm going to call it round over 1. Oops. Learn how to spell, Mark. Round over 1. And we'll calculate. And then we're going to preview that. And we see we get a nice round over. Okay? Everything looks good so far. We see the top is not 100%. We got a little bit of a line here. But that's okay. We can clean that up with a little bit of hand sanding. But what I've done is I have prevented the top of this radius right up here at the top. No, right up there at the top, excuse me. I've prevented that from going down into the top surface of the material. Now, if 0.23 is not quite enough, you can go 0.24 if you'd prefer. I just find that it's real easy to clean that up. And on something like this, I would just use a sanding block on the top and just kind of roll that edge as I do. It's not a big deal. But now I need to do my cutout. Come on, zoom back out. There we are. Turn on the vectors. I'm going to select that vector. I'm going to do a cutout. Z equals. And I'm going to use a 1/4 inch end mill. And just fair warning, I try to match the I try to match my cutout end mill to the radius if it's at all possible. Simply because if I use a 1/8 inch radius to round over the top of this and I cut it out with a 1/4 inch end mill, any inside corners, you're going to have a lot of cleanup because that 1/4 inch end mill is not going to reach in far enough to clean up the edge, the inside edge on an inside corner. And I can demonstrate that in a minute if you'd like. Okay, I'm going to cut all the way through. I got to select my end mill. I've got it here, select, and I'm going to cut outside the vector for this. I'm not going to change anything down here. I just want to call this cutout. And we'll calculate. Whoops, I didn't select it. I thought I did. Turn on the vector. Select it. There we go. Now calculate. All right. And there we see the toolpath. Let's go ahead and preview that puppy. And here we see what Kimberly was talking about. That little ledge right there. That is... Let me find it again. Come here. That is that flat tip. That's a little ledge there. And that ledge is going to be a 1/64 of an inch wide. That's a lot of sanding to get rid of that. So what we're going to do, we're going to reset the preview first of all. We'll back up to the top. Close. And I think I'll do a totally new round over so we can compare the two. Yeah, as a matter of fact, what I'll do, I've got this selected in move and transform mode. I'm going to hold down Control, and I'm going to drag a copy over here, and I'll do it on this one. So we'll go here, and again, I'm going to go back up to 0.23, and I'm going to select my my round over bit. There we go. And I have written my offset allowance in the notes for this bit. So I know this is 0.013 is my offset allowance on this bit. I've done testing with it. Okay. So I'll select that bit, and my allowance offset's going to be 0.013. And I'm going to select on the vector. Now, I'll come down here, and this is going to be round over 2. Calculate. And then I'm not going to run it yet. I'm going to do a cutout, 0.75, with a 1/4 inch end mill. Select outside the vector. I'm not going to change anything else down here. And we'll say cutout 2. And we will calculate. All right, we'll preview just those. Preview those visible toolpaths. Oh, I still gotta. Oh, I gotta go negative. Oops. Reset. It didn't let me go. Didn't let me go. Ah, that's right. Outside. Outside. When I'm using an allowance offset, I got to go outside. It won't let me go on the vector. Come on, Mark. Wake up. All right. Preview visible. Shaboom. You're making me a liar now. You're making me a liar now. It always works when I'm doing it by myself. It doesn't work when I'm live. It grays out the allowance offset. Not doing a separate last pass, that will not help. I've not noticed that before. I've always done it and it's worked just fine. Well, I have another option, and that is I can create another vector that's 0.013 larger, but that just confuses things. Well, now, dadgummit. Oh, Kimberly says, okay, all right. I just copy the vector with the offset. Yeah, you can do that. You can do that. Rich says, I've been using IDC's roundover bits without any shelf issues. Garrett seemed to have a pointed cutter. Okay. Just need to be careful about zeroing the Z height. Okay. Okay. Careful in which way? I mean, careful in which way? Careful in what way? Are you talking about not using the touch plate, or what's that? In what way? I'm real interested in that. So let's go about it Kim's way, the way she does it, and we'll just do that. So we will close this, number one, close, jump back over to the design side, and I'm going to take this, and I'm going to offset it outwards, 0.013, and I'm going to select the new one, offset. Now we'll use that one for the roundover on the vector. Calculate. Now we'll preview those. And there we have the nice smooth side with no shelf. Maybe that's what I did. I haven't done this in so long it's not even funny. Maybe that's what I did. Okay, reset preview, close, go back to top, and we're going to go ahead and just preview all the tool paths. Preview all tool paths, and you can see the difference just by introducing that offset because of that ding-dong tip that is not actually an infinite point. That's a lot of sanding. That's a lot of sanding. Okay. Butch says, I believe using the touch plate with IDC bits. Yeah, you really have to be careful with those carbide bits that have an infinite point. And there are some manufacturers that have them. Let me grab my 15-degree B-bit. Of course, now that I want it, I can't find it. There we go. you have to be careful even taking these puppies out of the tube. This one's on a Mana 45611K, and I will I'll put a link to it down in the description of this video. Let's see, can you see? That's an infinite point on this 15-degree V-bit. And that sucker bites. It bites hard, and it does not care. Just dragging your hand underneath it, you will have scars. It's wicked. But you cannot use a touch plate or tool height setter with this bit. It will shatter that quicker than you can say boo. And in fact, I broke one. I broke the tip off of one, putting the brush on my dust collector because I didn't bring it down just low enough and then bring it back up. So it just clipped the tip of that bit, snapped it right off. So, okay, Kimberly says, so at the final thickness is a 1/2 inch, and I want the side radiuses to be top and bottom 1/4 inch of the total each, or 1/4 of the total each. In the center, you're confusing the stuffings out of me. So if the final thickness is a 1/2 inch, and I want the side ratios to be the top and bottom 1/4 of the total, and the center half the total of the width. Is equal to the hypotenuse of the other two sides. No, that's the wrong one. Wow. Like an Oreo cookie. Okay, well, you're not going to get that with a 1/4 inch roundover. You'll need to go with an 1/8 inch roundover. So what you want is 1/3 up. You want an 1/8 inch roundover. Then the bottom, you want an 1/8 inch roundover, and then flat side in the center. You'll want to go with an 1/8 inch roundover. And with a 1/2 inch diameter, the black part of the Oregon round, I think you mean Oreo roundover, and the white flat. Okay, yeah, I get you. You'd want an 1/8 inch roundover, and then you'd want to cut it out with an 1/8 inch bit. All right. And let's, do you have any inside corners? Because I'm going to show you something to be careful of. We'll reset the preview, bring that back up to top. Close the preview. I'm going to jump back over here to the design side. Go into the 2D view, and what I want to do, I want to make a rectangle down here, and then another rectangle over here. We'll close that. Then I'm going to select both of these, and I'm going to cut out, subtract the second vector from the first. So here's the first. Hold down Shift. There's the second. And I'm going to subtract the second vector from the first, clip that, and shaboom. So now I've got that vector. Okay. Now let's go over here. And first thing I'm going to do is another profile. And I'm going to cut to, I'll go 0.120. I got my decimal in there, so 0.120, and hope 5/1000 is enough. And we're going to go with the 1/8 inch roundover, boink. And what is my, oh, I didn't put my offset in here. Well, that's okay. We'll try. This is not about that shelf. This is about something else entirely. And we're going to use that roundover. We're going to go on the vector. And we're going to call this round over 3. Then we'll calculate it. Now I'm not going to preview it yet. Close this, do another profile toolpath, cutting all the way through, 0.75. And we'll select the proper end mill. Select, and we're going to go outside the vector. Nothing else. I'm just going to cut it out. We'll call that cutout 3. I'm not screen sharing, of course. Thank you. I apologize for that. I've got this here shape. I'll show you how I made the shape again in just a second. Let me start over. Okay, let me start over. I'll delete that. Delete this. Jump back over here into the 2D view. I'll delete that. Now, I'm going to take a rectangle here and just make it sogy big. That's good enough. Then I'm going to take another rectangle and make it sogy big. There. Close. Now I want to subtract this shape from this shape. So this is my first shape. I'll select it, hold down Shift, select this. Then I'm going to come over here under Edit Objects, right here. Subtract the second selected vector from the first. Click that, and it took away this vector and left that shape. So we'll select it, go back over here, and we'll do another round over with an 1/8 inch bit. So I'm going to go 0.12 with a 1/8 inch radius point cutting router bit, cutting on the vector. We'll come down here, and I will name this round over 3. And we'll calculate. And I'm not going to worry about doing this just yet. Close. Now, using the same vector, I want a profile toolpath, cutting all the way through, 0.75. And we'll get the proper end mill, 1/4 inch end mill, select. Machining outside the vector, and we'll call this cutout 2 or 3, and we'll calculate. Now I'll preview these one at a time to show you what happens if you use a end mill that has a smaller, tighter radius than the if you use a round over bit that has a smaller, tighter radius than the end mill you're going to cut it out with. Okay? So we're going to preview that tool path, and there's our round over. Everything looks nice. Then we'll do the cutout. Get rid of the waste, and here we see the issue. That round over bit is able to get up in closer on that inside corner than this 1/4 inch end mill is. That's the problem. And if you've got a lot of inside corners, that's going to be a lot of cleanup. So what the best thing to do, let me reset the preview, is on your cutout, and because your material is only 1/2 inch deep, this will be easier for you, Kimberly. Instead of the 1/4 inch end mill, we're going to jump to an 1/8 inch end mill. Select that. Recalculate the tool path. Now we'll preview those two visible tool paths. And while it's not perfect, it's a heck of a lot closer. You're still going to have a little bit of cleanup right here, but not an 1/8 of an inch of cleanup. because the radius of that 1/4 inch bit has to stay out here to make this inside corner, you want to go with an end mill that is at a minimum the same diameter as your radius, if it's at all possible. So when you cut an inside corner, you're always going to have a radius. But it's the amount of cleanup you want to do that's going to be the deciding factor. And I think that's the same tip width. I need to put my offset for the 1/8 inch bit. I haven't cut with the 1/8 inch bit yet. That's the issue. Fortunately, no inside corners for this project. Well, you're ahead. You're ahead of the game. So, hello. All right, then we'll reset the preview, and so that's the name of that tune. Basically, and yes, sometimes handwork is required. I have yet to get a project off the machine that was finish ready. It just doesn't happen. You can get ding dong close, but you're always going to have a little bit of handwork, a little bit of finish work, you know. Offset half of what was used for the roundover. No, it's going to vary on the bit. Each bit, I mean, they'll get as close and consistent as they can, but each bit's going to be different just a little bit. And that tip on that 1/8 inch roundover may be the same width as it is on the 1/4 inch. So the best way to figure out what that offset is to get a piece of scrap wood, and this is where an old fence picket comes in real handy, and just, you know, surface it so you've got one good side, and then do roundovers. You know, get yourself a machinist scale and measure and put that in. Start with that. Start with half of that measurement. So in my case, 1/32 ends up being 1/64. And just start there and test and try different offsets until you find the one. And then when you found that offset that works for you, put it in the notes on that tool. So next time it's right there handy. So this is where scrap wood comes in real handy. And I've said it before and I'll say it again. My number one source for scrap wood that I can test on is the free section on Craigslist. Because somebody is always throwing away a chunk of material that if you don't take it, it's going to the landfill. And I have absolutely no philosophical problem with cutting up a chunk of material that was headed for the landfill rather than something I or someone else purchased, you know. And if you've had any windstorms in your area, somebody is replacing a section of fence. You can always find scrap wood that somebody's getting ready to throw away. First time I was learning to use the rotary axis on the old Gatton CNC, I found a guy who had... he had 3, they were deck balusters, just the simple cedar posts that went from the top of the deck to the side of the rail. He had 3 of those he was going to throw away if somebody didn't come up and take care of them. Okay, Tony's wondering, could you use a V-carve toolpath to just clean up the corner? No, because it's going too deep. And the only way to get more depth out of a V-carve toolpath is to either lie about your start depth or use a very steep tip, a steep angle, like a 15 degree or 10 degree. And even then, it's depending upon the thickness of your material, it's not going to carve the right way. It's going to take a lot of that radius out when it comes up to the top of that carve. I see where you're going, square corners, but no, that's not gonna work. So And remember, a V-carve toolpath will cut inside the vector. So now your offset is just shifted to the inside for that corner. And it's going to attempt to V-carve the whole thing. So can you show the flip with the marking pins next? I'll tell you, I'll do one better. I will post my first two-sided machining project where I show that out on the machine. After I've created the two-sided project, I show how I had screwed it down. I'll show how I unfastened it, took it off the marking dowels, flip it over, and seated it again, then screwed it back down. The thing you have to remember when you are talking about a two-sided carve, and once you have that light bulb moment, you will not forget it. You will get it. Everything will be just like, oh, what was I worried about? You know? The thing to remember about a two-sided project is right here. Which direction are you flipping? Are you flipping top to bottom along the Y, or are you flipping side to side along the X? I always flip from side to side. I don't know why. I just prefer it that way. I would imagine they work, and it's going to depend on your material. If you've got something long and ungainly, it may be easier to flip side to side. If you've got something short and wide, it may be easier to flip from top to bottom. But you've got to remember which way you went when you go to do this, because that is going to, if you mark side to side and you accidentally flip it top to bottom, nothing's going to fit. Nothing's going to work. So, especially if you make things Murphy-proof. Cancel. Thank you. And when you do your, we're going to go with a quarter inch diameter. Yep. When you do your alignment peg holes, you make them asymmetrical. Then they can only do them they will only fit one way. They will only fit one way. Now, Steve, the man, there's a two-sided machining playlist. I'll do that first. I'll do that. I'll post that link instead. And that's a playlist. I believe it has 6 videos in it. I may be wrong. But that's the link to the playlist. I would suggest watching in part 1 of the first one. I designed the project and I go through how I placed, I'm using my cursor over here, how I placed these and showed why I placed them the way I did. And with the second video is where I went out and I actually cut it on the machine. Okay, Steve said there's 7 videos on the playlist. All right. Okay. Personally, I think they're all great, but, you know, I'm maybe biased. Yeah. The thing is, make sure these are asymmetrical so they'll only go one way. And make sure when you go to flip, you flip the right direction. So, and that's all of that. But fair warning, Kim, fair warning. Once you have that light bulb moment, once you get it and go, oh yeah, all right, I got it now. Two-sided projects become addictive. I went out of my way to make two-sided projects. I looked for a reason to make two-sided projects because I just dig it. I loved it. So, and always, always, always put your cutout, your final cutout, on the last side you have to machine. Even if it's something simple like a keyhole, make sure your profile cutout, your final cutout, with or without tabs, is on the last side you're going to carve, and it's the last tool path you cut. So, because it's really an SOB to cut out a project, then discover you've got V carving to do on it, even if it's something simple like a signature or again a keyhole. Now it's loose from the rest of the material. So, and order of operations, I always use the round over bit or the V bit, no matter what I'm doing with either of them. I always use them before I do a cutout or a clearance pass. If I'm V carving and I'm using a 1/8 of an inch end mill, or a 1/8 of an inch, a 1/8 of an inch end mill is my clearance tool, I run the V bit first. Then I'll run my clearance tool. And that's because, let's say you've got a thin ridge on one of your carves. You're carving out over here, then you're carving out around it, and you've got this thin ridge. If that's already cleared away and you've got that ridge standing up, now that V-bit has to try to follow it without it breaking loose and flying across the shop. When it's all solid material, that V-bit can come in and do its V carving right there. Then you can machine away the rest of the material. So I always run the V-bit or the round over bit first. So Butch Miller says, I like to draw a flip direction arrow in some open space as a visual reminder. Yeah, good one. And if you create a job sheet, if you're using VCarve Pro, job sheets are not available in VCarve Desktop. If you're using VCarve Pro or Aspire, if you create a job sheet, right up at the top, it shows you which direction your flip direction is, as just another reminder. So, okay, now there was another question up here. I have to scroll back and find it. I hope that helps you, Kimberly. Howdy, Daniel from VistaScope. How you doing, Daniel? All right. Let's see here. I wasn't sharing. We need a buzzer on his seat. Oh, Kimberly's bringing out the heavy artillery. I see how it is. I see how you are. You got the innocent face, but you ain't innocent at all. I think it's all in the eyes. The innocent face, but the eyes are screaming helter-skelter. Let's see here. There was another question up here. And where did it go? Oh, come on. I want to say it was... okay, there we go. Rich Bratcher says, Mark, if you have time, maybe. I'm trying to use a molding tool path to create a paddle-like carve. I can't get the tool path to cut from the center of the carve to the edge. It wants to cut from the outside edge of the paddle out. Change your start point. Change the start point on your vector that you're trying to cut that profile in. Because if the start point is down below and you're starting from there, it's going to go up, whether you right-click that vector in reverse direction or not. So change the start point. Make sure the start point is up in the center of the paddle, for lack of a better term. And make sure the direction it's going to cut is going down, going out towards the edge. So let's see here now. Joe Kelly says, yeah, I use an arrow too. Pointing right is top, pointing left is bottom. Okay. Yeah, tee-hee. Come on. Tee-hee. I do need a co-host. He says, I'm trying to, but I've not found it, but I'll try again. Okay, remember, let me share again here, and I'll come up with, let's do an arc, and we'll go here to, and let's see here. I want to go here, and no, I want the radius to go over here. Okay. Close. All right, now I've got this, and I want to do a, use this in the molding toolpath. So we'll shoot over here, and I got to close my preview. I'm going to do a molding toolpath. All right, now here is my drive rail. Now I'm going to hold down Shift, and here is my profile. Now, what I'm looking for, there's two things I'm looking for. I've got, this is my start point here, and we see how it's projecting outwards. It wants to cut this profile out this way. Now, if I right-click and reverse direction, it still wants to come out this way. Because on a closed vector, it's always going to project outwards. It's not going to let you come back in. So what I have to do is I have to cut this vector and make it two vectors. So let me close this. And I'm going to go into node editing, and I'm just going to cut the vector here. And I'm going to cut the vector here. Okay. Come out of node editing. Select them both. Molding toolpath. Now I've got this going on. Right click. Reverse direction. Here is my profile. Hold down Shift. This is the direction it's now going to cut. Okay. But look at the direction on this arc. I've got my start point up here, and it's going down in this direction. That's how I want it to cut. Now, you can right-click and reverse direction, but that just means it's going to start cutting down here and move up. So if I right-click and reverse direction, it's going to start up here and it's going to move downhill. That's the way I want it to cut. Okay, let's see. I got my drive wheel. My toolpath position is okay. I'm going to use for this, yeah, I can use a 1/4 inch ball nose. I'm going to vary the step over, which means as it goes around this radius, the step over is going to get tighter and tighter and tighter and tighter and tighter. So I want to vary the step over, and I want to skip the flat regions up here. I'm not going to worry about a larger, well, yeah, I'll use a larger area clearance tool. Not going to machine the flat regions. Create sharp corners if it's at all possible. I got an inside corner here. It may not be possible. I'll calculate it. All right. Now I'm going to preview the clearance that uses the 1/4 inch end mill. There ain't nothing there. There ain't nothing there. The 1/4 inch end mill is too big. So we'll preview the sweat profile. And what do we got going on here? It went the other direction. Oh no. We want it to go outwards. Undo last. Do we want it to go outwards? Oh, 2D view, Mark. carve the other way. Let's reverse the direction. And let's give this a shot now. Yep, if it's going to happen, if it's going to be wrong, it's going to be live. No, it's going to do the same thing. Okay, swept profile. I think we're kind of stuck, Rich. Let me 2D view. Hello, 2D view. Oh, I left them drawn. Let's get out here. Let's reverse direction and see what happens. I think the reverse direction is I'm going to be on this. Calculate. Now let's see what we do. I got all kinds of... Oh, okay, it's not holes. All right. We're going to preview this. Still nothing because it's too big to fit down inside of where it's going to cut. And it left those undone. Things just keep getting better and better. Yep. Okay, I did want it to project outside. Okay. Anyway, let's reset preview, close. Let's go back. I've got that selected, design. We're going to join, so we get one closed vector. What do you mean one closed? Oh, okay. Yeah, I'm going to, well, yeah, I'll join, close. Now select that, select that. Yeah, that's going to work. Okay. Still not going to get anything out of the clearance because that bit's too big to fit down in there. Preview selected toolpath. That's the direction we wanted to go. Okay. And it did start from the top, then work its way down. There's your initial plunge down here, and it's working, and we can see how the tool paths are getting a little bit closer together. The passes are getting a bit closer together when we get, as we get down to the bottom. Okay. So basically, Rich, it's within here, it's changing the direction of the cut to get it to start up here and work its way down there. So you'll have to excuse my brain today. Man, I think I'm still on the highway. All right. Well, let's see. Were there any other, what do we, I think I had another question. Okay. From Joe Kelly. I used a zero plane today for the first time. Is there a way of setting it to a certain height in the job? Yes, there is. Let me get rid of all of this. Delete. Now, what are you using the zero plane for? Because remember, the zero plane has, it is in VCarve, it's right here. When you put a zero plane on the material here, and I'm still in preview, reset job, close, then go back over here. A zero plane basically covers the top of your material. Now, if you are, and the main use of a zero plane is if you're cutting a dish, it's going to fill in any jagged edges in that dish. Now, if you're forcing your model, so your zero plane is going to be part of your model. If you want your model to be further down inside the material, for instance, you got an 1.25 inch piece of material and you want your model's only 1 inch thick, so you want to get through that other quarter, that's going to happen over here in material setup. You're going to position your model down within the material. So if you want that, let's say that zero plane is the top of your model, you're using 1.25 inch, for example, material, 1.25 inches, and you want your model thickness to be 1, you're going to set your model down at the bottom so that it cuts all this away before it gets to your model. So you can set a gap above the model of 0.25. Oops. 0.25. There we go. And set. Set your model height. Model height is, in this case, I'm using 3/4 inch material, so the model height is 0.495. Oops. 0.495. Well, I don't have a model here, but you get the idea. You'll set your model position here. Now, if that's not what you're wanting, if you're wanting to put that if you're wanting to put that zero plane, okay, adding the STL on top so I have a flat base for B-carbing. Generally speaking, yeah, I'm not sharing again. Generally speaking, you shouldn't have to do that. But if you do for some ungodly reason, let's take that down here. And what we'll do is, here's where I was adjusting everything in material setup. Cancel. As you come over to your toolpath tab, material setup, and you'll put your position, your model position within your material right here. Okay. Then hit OK. And no, I'm not going to recalculate anything now. If you need to change the position of the zero plane, what you're going to have to do, let's say you carved a dish and you want that zero plane down inside that dish for some reason. You'll have to go over here to the component tree. Remember, the zero plane is a component. It's part of the model. So we right click, we come down here to properties. You need to figure out at what level do you want this zero plane. So if you want this zero plane 1/4 inch down from your model, you'll come up here to base height. Okay? And we'll go negative 0.75. Okay? Let it catch up. Close. And now if we look, we have a little shadow here. You have a shadow right there. That's the top of your material. And the bright orange, that's your zero plane. Okay? When I click off of them, you can see what I'm doing here. So that's your top of your material. And here is your zero plane. Okay? Now, I can show the block. That's the block of material currently. That's 0.75. And all I did was I clicked this icon right here. So this is 0.75 inch thick material. And my zero plane is 1/4 inch down from the top of that. So it's click, and I'll turn that off. Right click, go to properties, and it's right here, the base height. A zero plane has a shape height of 0, and this is grayed out. I can't change that. Its thickness is 0. So you just go in and set your base height. And if you're moving it down within a piece of material, it's always going to be a negative number. So the short answer to the long question is yes, you can adjust the height of the zero plane within the material. But remember, it does not have a thickness. So, let's see, Steve, you need a chair zapper to remind him. And Steve says, wouldn't help. No, it wouldn't. No, it wouldn't. What I need is a co-host. I need to find me a co-host. But that's okay. This too shall pass. Remember, zero plane, make the whole thing a model. Yes, the zero plane becomes part of the model. And if you, this goes back over here to the component tree, if you now start adding components onto this, remember it models from the bottom up. Everything you do from here on will be added or merged with or subtracted from that zero plane. So, and people wonder, how come I don't see a zero plane out here in the 2D view? Well, it's very simple. You come up here to your layers. There's your zero plane layer. And when you look in the 2D view, you can turn it on, but all it is gray. That's why it's, yeah, and once again, I'm not sharing. Pardon me. Medications are hitting hard. There it is. There is a zero plane layer whenever you add one. And the reason it's not visible in the 2D view is because it's just gray, and it'll cover up all the vectors on your, it'll cover up all the vectors. So it is off by default, but the zero plane is created on its own layer. And currently, because I only have one level, it's on its own level, and I only have one component. So now, I get asked this every once in a while, and now's the perfect time to say it. What is layer 0? I imported that white side point cutting roundover bit. I imported that DXF file. DXF files have a layer 0 that is not used by Vectric. Generally speaking, layer 0 is going to be empty. If you look up, you'll see it's here to zero plane. It's got something in this icon right here. That's because there is data that Vectric uses on that layer. There is nothing on layer 1. Absolutely zero. And you can tell that because that sheet's blank. Layer 0, that's blank too. Now, layer 0 may or may not have data in it. But layer 0, 99% of the time, contains data like tables that show scale or part suppliers or information about the drawing, such as we saw with the white side bit. Their telephone number and all that other stuff is usually in layer 0. Not always, as we saw. If they want that to be visible, they know to put that in the layer with all the artwork. It won't be put in layer 0. Vectric generally does not access anything in layer 0 because it's not usable artwork. So you can come over here to this icon right here, and you can delete this because it's empty. You don't need it. But check to make sure there's no data in layer 0. And the way you check is, let me Control Z to undo that. I don't think I can do that. Can I Control Z to bring that back? Yes, layer 0 is back. The way you check is turn it on. Make it the visible layer, then turn everything else off. Do you see anything? No. So we know that it's not in use and it has no data. Come over here, delete this. Boom. You don't need it. Now layer 1 is my active layer. I can put in my artwork out here and we're all good. And if I come back up here and look in the layer manager, now you can see there is something in this blank piece. That means there's data here that Vectric is using. There was artwork, or there's a toolpath associated with it, or something to that effect. It has data. So if I add a new layer, for instance, and there's nothing on it, or I have layer 0 up here and there's nothing in it, I can come over here to this and I can hit delete empty. and all of the empty layers is going to get deleted. So I can just go boom, 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 boom. And whatever layers I don't use after finishing this design, I can just delete empty and they're all gone. So, H Center is asking, is there a way to stretch out a profile cut? In what way? Physically, or are you talking about the time? Like on a deviled egg tray, create a fluted path that centers itself between them cleanly. Create a fluted path that centers itself between them cleanly, if that makes sense. I don't understand stretching out a profile cut. Create a fluted path that centers itself between them cleanly. Are you talking about, for instance, little finger holds so you can reach down in and get said deviled egg out of there? Or I'm using my hands like you can see them. But I mean a molding path, not a profile. Like I said, what's the use of it? Are you going to be See, the length, if you're using a molding tool path, the length of the cut that it makes is going to be dependent on the profile that you create for it. So if we've got, let me get rid of this here, delete. Talking about an egg tray, and I've got, well, what have I got? I got a 12 by 12. Yeah, so I'll make a circle that is 10.5, and I'm going to put it on my X0, Y0, 10.5-inch diameter. Yes, okay, we're good. And we're going to create that, close. And now I'm picturing a string of pearls with the egg holes as the pearls. Okay, trying to make a gap in between the egg trays, but the gap space is molded, hard to explain. There are several ways to do it. As Michael Mazalik would say, there are at least 3 answers to every question. And there are several ways of doing it. Okay? Let's say your deviled eggs are here. And I'm going to take that and I'm going to do a circular array. And the rotation center is going to be the center of the material. I want to rotate the copy. I don't think I can get 12 around this, so let's go for 8, just for giggles, okay? And we'll copy. Hey, that worked. That was good guessing. All right, now, you want a groove in between these. Like you said, as a string, imagining a string of pearls. The distance between the edges of the egg trays. So I want the gap molding stretched to keep it even. Offset doesn't work because it's a fixed distance. Okay, let me see if I'm getting this right, okay? What I want to do is I want to bring this no, I'm not going to even do that. I'm going to come up here with a circle. I'm going to start in the center, and I'm going to drag it out to about right there. Center of one of those egg trays. Okay. close. All right, now I'm in VCarve Pro, so I cannot create a 3D model to carve these out. Okay? I can't create a 3D model to carve these out. But I can cheat. I can come down here to Clip Art and come down here to Domes and Dishes. And I'm going to go with I think a 45-degree dish. And, well, I should have done this before I even put the first one in, but what the heck. I am going to take one of those and set selected object size, and we have 1.6 by 2.4. 1.6 by 2.4. So, I'll make this, I'm not going to link XY, 1.6 by 2.4, 2.4. I'm going to apply it. Close, grab it, bring that up, and I'm going to center it right there. Now, I'm going to select this, hold down Shift, select the vector. Then I'm going to come over to alignment, and I'm going to align the selected object to the last item in the selection. And I'm going to go vertical and horizontal. That puts that in the center of that vector. Close. And now I need to go into my component tree. And I need to change the combine mode to subtract, turning it into a dish. Okay, design, still selected, zoom out. And I'm going to do another circular array using the exact same settings. And again, my rotation center going to be X0, Y0, 8 items. I do want to rotate the copies. Copy. All right. Close. So now I have my egg dishes. The dish part is easy enough. The space between them, if centered by percentage, would be a curved V shape. You may have to draw individual vectors for that, because I'm still kind of not getting what you're trying to say. So I think I understand what you're trying to do. You're trying to put like a little dish in here running between each of the trays. So I'm going to select one of these, go into the component tree. I've got that selected, and there are my copies up there. And I'll look at the properties, and its depth is 0.2849. I'm going to go 0.1. I'm going to go 0.18 on the next thing I do here. I'm going to use Profile Toolpath. I'm going to select that vector. I'm going to go 0.18. And the bit I'm going to select is a 3/4 inch bowl and tray bit. Select. I'm going to go on the vector. Then I'm going to calculate. Now the first thing it's going to do, it's going to carve that. Close. Now, I'm going to select all these vectors. Hold down Shift and deselect this one and this one. I'm not going to do a roughing toolpath. Normally, I would. Normally, I would do a roughing toolpath. I can get away with an 1/8 inch tapered ball nose. I'm using the selected vectors. I'm using them I want a boundary offset of 0 in this. Well, no, I do want a boundary offset. And I'm going to do raster. I'm going to leave my raster angle at 0. Normally I wouldn't. I'm going to calculate. Ignoring duplicate vectors, the 8 remaining vector. Okay, fine. And we'll preview that toolpath. I shouldn't have used that vector offset. Stop. Undo last. Let's go back into my finished toolpath. And we're going to get rid of that boundary offset. Backspace. Calculate. Ignore the duplicate vector. Somehow I got a duplicate vector in there. Okay. All right. The dish part is easy enough. The space between them is centered by percentage should be carved V-shape. Like the inside of a clock face, it's the bottom of the V. The outside of the clock would be the 2 lines of it. The groove is not going through them. In your example, there's 8 of these to do. Okay, the groove is not going through them. Now, you know what it is? That damn 0 plane's 1/4 of an inch down there. Undo last. I forgot about that. Component tree, 0 plane. Properties. Put that base height back up to 0. That's what is goofing me up. Close. Let's recalculate that toolpath now. Yeah. All right. Now let's preview this puppy. Now, you see how this goes. It goes down into, it cuts into the sides. Okay? That's not what you're looking for, is it? This is one way of doing it. You'll have the finger grooves, but it looks funky when an egg is removed. I think what you're thinking about, let me reset the preview, is more like a deck of cards. So you would want something starting here, for example, and plunging downward, and starting, say, here, for example, and plunging downward. Correct? Okay, create offsets around each egg. You'd have to just create one offset the way you want it out here in the 2D view. We'll get rid of this. Delete. Now I'm going to select vectors, all duplicates. And there are duplicate vectors. We'll delete those because I'm tired of that warning. So, closer to the center, the lines connect to each other. At the outer clock's face edge, it's spread out more. Okay, I would have to see the design to try to figure out what you're trying to do. All I'm saying is if you are looking for something to go into here or something out here, are you talking about lines radiating out this way? But you want a molding toolpath. Well, either way, what you're looking at is you're looking at creating the diameter. Yeah, send it to me via email. I would appreciate that. Without seeing what you're trying to do, I'm kind of guessing. I'm in the dark here. So, but if you want to know how to make a deviled egg tray that'll hold 8 eggs, there you go. Take one dish, make it a dish. Number one, you set your combine mode to subtract, size it to fit the vector surrounding your egg tray, then create a circular array, do the same thing with the vectors, then here's your outside cutout. That'll give you a flat edge. You could put a chamfer, you could put a round over, as we discussed earlier. But there's a way to make a deviled egg tray. Now, I have a question for you, 8th Center, and please don't take this the wrong way. You're in the UK. How the heck do you know about deviled eggs? I thought we kept that secret. I'm going for 12 halves actually, but irrelevant at this point. My point remains. You're in the UK. How do you know about deviled eggs? That's one of our culinary secrets that we don't let out of the country lightly. And if you've had deviled eggs, you know why. You know, it's funny. It's weird. I think that, well, you Americans think you invented everything. No, it's not that I think we invented it. It's just that if you mention deviled eggs to your average Brit, they have no clue what you're talking about. They have no idea what you're talking about. Deviled egg? What the heck's he mean? You know. But you put a plate out, and they quickly become just like me. And between you and me, 8th Center, I can eat my body weight in them. And it's funny, I won't look at eggs in the fridge twice. I mean, I don't care if I have an egg. But if there's a tray of deviled eggs there, somebody better put a guard on them, because I'm right there. I could eat my body weight in deviled eggs. Of course, you wouldn't want to be around me the next day, but that's something else. Yeah, I know, and I don't know where it got hidden, but it's kind of like poutine to the Canadians. They don't let it out of the country lightly, you know. And I'm on a one-person quest to get poutine down in the States. I'm serious. Oh, I'm not doubting that you know lots. Don't. It's just every Brit I've ever talked to, and I talk to more than my share for an average American. Every bit I've talked to, the subject of deviled eggs has come up. They're just like, what? What are you talking about? And it's like, hey, you know, if you know, you know. So, all right. Hey, anyways, the British brought them to America in the 1800s. That doesn't mean anything, Steve. They also brought the word aluminum, but that's another fight for another day. And about the same time, no, it was 1700s when Sir Humphrey Davies discovered aluminum and called it aluminum. And then a bunch of toffs over at Cambridge decided to change it. And we got the memo. We just burned it and said, nah, aluminum's good enough for us. They seem to have forgotten. They also forgot that they brought the word soccer over to the States, because that's what they called it at the time. Anyways, we're going to leave it at that. I've caused too much controversy without bringing the whole aluminum or aluminium. We also now know everybody has their price, Joe. Everybody has their price. And most Americans won't admit it, but they're like crack. I mean, addictive as heck. So anyway, almost, you know what? Scotch eggs are also addictive too. And yeah, I loves me some Scotch eggs. I hope you're watching, Linda. I loves me some Scotch eggs. Anyhow, let's go ahead and wrap this up. Sunday, tomorrow night, channel members, we are, Howard McCall. He might have to come on and give us a recipe. Deviled eggs made with jalapeno relish are the best. That's intriguing. Anyhow, see, now, y'all, we always devolve into food, man. I said that earlier when Butch Miller, the Marine, was talking about crayons. Anyway, tomorrow night, I don't remember what we're going to do. Just join us. It'll be good. It'll be fun. Hopefully, we'll have the whole crew back now that folks are back from where they've been and visiting and taking care of business on the home front. I don't know what we're going to do, but it's going to be a good one. So, tomorrow, I haven't created the live stream yet. That's why you haven't received the email notification. I'm going to do it as soon as I get these links put down in a pinned comment at the very beginning. And or a pinned comment, you'll see it at the top of the comments when you come back. Then Thursday we have our 3D printing hangout. John and Mike showing us some different design softwares for our 3D printing projects and working us through that. Then Saturday, every Saturday except last night for some ungodly reason, I was on the road. And we didn't have our Zoom BS session. So maybe we'll take care of that and do one. I don't know. Maybe we'll have a surprise one during the week, just to make up for Saturday. If you don't know what I'm talking about, or if you don't know, if you would like some more information on how to become a channel member and take part in some of these perks and get a little bit more personalized, by all means, do hit that word join. You'll see join down here below the video panel someplace. And click that where it says join. You're not joining anything. No obligation. All it's going to do is it's going to pop up another video. It's going to tell you all about channel membership. We got a great group of people that are channel members. They're all involved in the WhatsApp group. Well, not all of them are involved. And if you're not part of the WhatsApp group and you're a channel member, number one, shame on you. Number two, come on, there's plenty of room. We have a WhatsApp group. For those of you who don't know, WhatsApp is not social media. It's an encrypted texting program. Europe loves it. Asia loves it. For some reason, it hasn't really caught on here in the States, and I'm also on a one-person quest to change that. I think that's about it. Anyway, we'd love to have you. Next Sunday, I don't know what I'm going to do, but that's where you come in. All of this we did today was one person's suggestion. Kimberly came along and said, Mark, how do you do this? And then somebody else came in and had another question. And the 8 Center came in and had another question. So next Sunday, maybe I will get a hold of, I'll have an answer for 8 Center and we'll do some work on his so we can show everybody what he was trying to get done today. Maybe. We'll see what happens. I still may not know what's going on. But I do have an answer for somebody out here. They just asked a question. Ellen asked, can the poppers be smoked? Yes, they can. You're talking about stuffed jalapenos. There's a thing called an ABT. Some folks call it a Texas bullet. And just make your popper the way you would, and then wrap it in bacon, put a toothpick through it to hold the bacon on it, put those on the smoker. Some folks call it a Texas bullet, and other people call it an ABT, which stands for Atomic Buffalo Turd. There, I said it, and I'm glad. Deal with it, YouTube. It's more than 30 seconds into the live stream. Anyhows, we're going to go ahead and get on out of here. Thank you for spending part of your Sunday with me. If you have comments, questions, concerns, suggestions for guests you'd like to see on the big program, put them down here in a comment. Leave me a comment. Leave me a thumbs up on your way out. It's free, and it helps out a lot. So, yeah. We'll see you next week. In the meantime, go do something cool. Or if you've been doing cool things all weekend, just chill. Instead of making chips, eat some chips. I mean, you deserve it. Relax. It's okay. Y'all have a great rest of your day, and thank you very much for hanging out with us, y'all. Bye-bye.